today we're going to focus and concentrate on trigonometry. Okay, assuming that if we have a right triangle, something like this one, so we know that in front of the angle of theta, that is indicated of course here, we will see that there is an opposite side in front of that, and there is an adjacent side that is close to that, and also hypotenuse, which is the biggest side here in this right triangle. So we would say that if we have this triangle, right triangle, we can write like sine of theta. Let's say that this is sine of theta. Okay, let me just write it better. Sine of theta is equal to opposite, let me write it as opposite divided by hypotenuse, or opposite over hypotenuse. Let me write also hypotenuse here. Okay, hypotenuse. So another definition that we can say is that cos or cos of theta, again theta is equal to, let me just use parentheses here, okay, is the denominator is also the same as sine, which is hypotenuse. So let me write it as hypotenuse, and denominator is equal to adjacent, so this is going to be adjacent. So far we've got that sine of theta is equal to opposite, the side, divided by hypotenuse. And also we've got that if we have the cos of theta or cosine of theta, we have it as adjacent divided by hypotenuse. Okay, we can also define another formula which we say that this is tangent. Okay, let's say that we wanted to calculate tangent. Okay, tangent of, again, theta. So what is our theta? This is our theta. Okay, so tangent of theta, let me just use these parentheses here also, is defined as sine theta over cos theta. So let me write it sine theta, just trying to write it a little bit faster, divided by, let me write it better, cos of theta. So let's write it as what we have here. So we would say that this one is equal to opposite divided by hypotenuse divided by adjacent divided by hypotenuse. So these two hypotenuse will be cancelled out. Let me just do this. So what remains is the opposite. Yeah, better to write it here. Opposite. What kind of P is that? Okay, opposite divided by adjacent. So because these two hypotenuse will cancel out in the denominator, what remains is the opposite divided by adjacent. So this means also tangent. Also cotangent is also the same as this one, but it's reciprocal. Adjacent divided by opposite, which is not very useful. Let's solve a question or a problem based on these formula. Okay, let's assume that we have a right triangle, something like this one. For example, this is a right triangle that we have it here, and also there is an angle, let's say for example here, this is our angle, our theta, and let's say that if this side is equal to 3, and for example this side, or hypotenuse better say, is 5, let's calculate theta. So how can we calculate this one? So we would say that because it's opposite, 3 is opposite, and 5 is the hypotenuse, and based on the formula that we have given here, we would say that 3 over 5 Okay. For example, if you wanted to solve a question or a problem here, here we've got a right triangle again here, and let's assume that we have the angle here, which is our theta here. Let me write a better theta using my pen device. Okay, fantastic. And then we are given that, for example, let's assume that this theta becomes 30 degrees. 30 degrees, okay. And then we are given that the hypotenuse is 5. The hypotenuse is 5. And this is our x, which is here, that we are looking for. So we would say that since this x is the opposite side and 5 is the hypotenuse and we have the angle, so the formula, based on the formula that we have here, we can see that hypotenuse opposite is defined as the sine of theta. So we could say that sine, write a better dot, okay, actually sine of 30 degrees, sine of this 30 degree would be 30 degrees, okay, would be equal to opposite again, opposite divided by hypotenuse. Opposite is x, so let's write x here, divided by hypotenuse, which is 5 here. This is the hypotenuse, okay. So we would say that from this equation, we can say that in the next part, the next line, we could say that x is equal to 5 times sine 30. So sine of 30 degrees. 30 degree. Okay, let's calculate using as we know that the sine of 30 is equal to half, but if it was degree, for example 36 or something else, we could also calculate it. So 5 divided by 2, or 5 over 2, is 2.5. So our answer would be here, x is equal to 2.5. Fantastic. Okay, let's solve another question. For example, if we are given exactly in this question, we could say that we have another one. For example, let's assume that we have a right triangle, again right triangle, in which we are giving with a degree of, for example, 30 degrees again, or better say 45 degrees. 45 degrees, and the side, the adjacent side will become, for example, 6. So what would be the value of hypotenuse? So we could say that we have the adjacent and hypotenuse and the angle. So now we should use the formula for cos or cosine, that is using adjacent and hypotenuse. So let's write that cos of theta, which is 45 here. Let's write 45 here. 45 is equal to adjacent divided by hypotenuse. So let's say 6 divided by x. So our x, let's simplify this one. We could say that x, if using this rule, cross multiplication, we could say that x is equal to 6 over cos 45. Cos of 45. Okay. 45. Okay, fantastic. So let's calculate this one using the calculator. We could say that 6 over cos 45 is equal to 6 times the square root of 2. Okay, 6 times square root of 2, which is 1.41. And let's say that the answer in terms of exact value, we could say it's almost 8.5. 8.5. Okay, great. So let's solve a better question, a little bit more difficult. For example, let's assume, for example, we have this right triangle, and that we are given something here. For example, there is some here as we have it here. Okay, there's a line here. So it is indicated that this side is equal to, for example, 2. This one is equal to 3, and our angle is equal to, let's say, 36 degrees. 36 degrees. Okay, let's solve this one. So first we need to, for solving this question or such question, we could say that we need the side. Okay, let's assume that this one is x. This one is our x. Okay, this is our x. Okay, this is our x. So when we are looking for x, we need to know this size, the size of this side. So how can we perform this one? So first we need to find out the size of the hypotenuse, and then we can actually subtract 2 from that, and then we'll got the idea about that. Okay, let's say that again, based on the formula that you're given here, we know that, look at here, okay, we know that we have the angle 36 degrees and also the opposite side, which is 3. We can say that we need only hypotenuse. So what formula should we use? It's exactly sine, because we are looking for the hypotenuse and we are given the opposite side. So let's say sine of theta, which is our theta is 36 degrees here, 36 degrees, is equal to opposite, which is 3, divided by or over our hypotenuse. Let's call it h, our hypotenuse, or a big H, better to say. Okay, so our h would be equal to 3 over sine 36. Sine 36. Okay, great. So let's solve this one using the calculator. We could say 3 over sine 36 would be equal to almost 5. Yeah, 5.1. Let's assume that this one is 5. And if we subtract 2 from this 5, we've got 3 here. This side would be 3. Okay, this one would be 3. So now we have the hypotenuse and an angle of 36 degrees and our variable, our x variable. So again, we need to apply the rule of the sine rule. So we could say that the sine of the 36 is equal to sine of 36 degree is equal to opposite, which is now our opposite is x. Our opposite is x divided by hypotenuse. The small triangle hypotenuse is 3. So we could say that x would be equal to, let's write it here, x would be equal to, just a little bit bigger, 3 times sine 36. So let's say that 3 times sine 36, which is 1.7 or maybe 8. 1.8. 1.8. So our x value here is equal to 1.8.